Hey, hi, hello. Hello, everyone. How are you?
Good evening, sir.
Good
Hey,
evening,
good
sir.
evening.
Fine, sir.
Good
Yeah.
evening.
How was the quiz? How did it
Good
happen?
evening, sir.
Good evening, everyone. How was the
Sir,
quiz?
good, sir.
It's
It's good. Okay. Did the revision session help you? How many of you have attended those sessions, revision sessions?
Sir, I have attended the revision sessions.
Sir, I have
yes, sir.
attended.
I have it.
The questions helped us a lot.
Did that help you?
Yes, sir, the
Yes,
questions
sir.
that
Most.
you gave for practice.
Okay. Okay. So week 6 we have to discuss, right? So what should we discuss? So should we discuss
Somebody.
summary session? Summary is not done or
Yes.
is it done?
It's left, sir.
Not
It's not done.
done.
So summary session.
Sir, summary, sir.
Summary, there is not much to discuss, but okay, I'll just take some 20-30 minutes. I'll just go through that.
Doubt clearing.
Yeah, so I'll just discuss in some 20-30 minutes the starting question, logarithm, and then we'll start with the doubt. Okay. I guess one session has already been done, right, for week 6. Correct?
Yes, sir.
Hmm. Okay. I'll just share my screen.
Excuse me, sir.
Yeah. Yeah.
Sir, are we going to have doubts of graded assignment after this summary?
Graded assignment we can't discuss, right? I can
Sir,
give you an idea, but I can't discuss the solution. Yeah.
sir, week 5.
Week 5 we are not discussing today.
Okay, sir.
Week 5 the deadline is done or is left?
Sir, yesterday it was.
That's done.
Yesterday,
Okay,
sir, it was
when
done.
is the deadline for week 6?
Fifth.
5th? It is yes, 5th was yesterday, I guess, right?
Yes, sir.
Yes,
No,
sir.
8th November, sir.
8th November, sir.
8th
6th,
November,
6th
sir,
week.
for the week 6.
Okay, 8th November. So you have 2 days more. Okay. So let's start with the logarithm function. So there's not much that to discuss, but okay, let's start this logarithm. Okay, so did you know the criteria for a 1-1 function? If a function
Yeah.
is okay, tell me which of the statement, 1, 2 statement I'm just saying. You have to statement first. If a function is strictly in, so what's the difference between a strictly increasing and increasing function?
Strictly increasing means the not equal to, and the increasing means equal to.
Yeah, so you're correct. So I'll just explain the difference between both two so that you don't have the confusion. Okay, saying while checking for the horizontal test. Okay, so there is two concepts, right? It's strictly increasing versus increasing function. So okay, tell me which of, so if you have a function something like this, is it a strictly increasing or is increasing function?
So it's increasing function.
Okay, it's an increasing function. Is it a 1-1 function? No, sir.
No, sir.
Yeah, so this is not a strictly increasing. Okay, it's just increasing because for 1-1 function, what are the criteria? If you are checking at some x1, x2, and if x1 is greater than x2, let's for example, this is x1 and this is x2. So the function value should be greater than fx2, right? if this is an increasing function, a strictly increasing function, but this is not holding, right? So this is not 1 function.
Sir,
So
strictly
whenever
increasing
you have to
function
check
is
1
not one function.
no, if this is a strictly increasing, then you can directly say it's a 1 function. If
Okay,
it's
sir.
not a strictly increasing, like just the increasing function, so I gave you the example, right? If a function is increasing also, and if this is the criteria, this can be a not 1 also, right? Because you can see that at 2 points you are getting the same values, right?
Yes, sir.
So that's right. Okay, let's start with this one. Log. You were aware of this, right? What is a here? A is the base, correct?
Base.
Yes, sir.
So you have something like this. What can be the value of a?
Greater than zero.
Greater than 0.
Not equal to 1.
Greater than 0. It should not equal to 1, right? So this is the both the criteria should be
Not
checking
equal
always.
to.
Yeah. This you should be checking always. And what are the criteria for x?
Greater than 0.
X should be greater than 0, right? So this is what we check, correct? So these are the criteria that you should be checking before solving any question. Of log. Correct? Yeah. Now tell me, what is this? Is this a range? Which is domain and which is range?
X is domain, Y is range.
Yeah, x is domain and y is the range. Okay. If you have something like this, a greater than 0, like this is the condition that is satisfied. Okay. So, and a is greater than 1. Okay. Let's, for example, a is 3. So can you plot? So can you tell me whether this function is a log of 3x? Is it a 1 function or not?
Yes.
What is
Yes,
the
sir.
plot for log 3x? Log 3x ka plot. How will you plot this log 3x?
It is an
What is the
increasing
inverse function
function.
of this?
It is an increasing function with the vertices is one is 1 0 and another is 3 1.
Correct. And what is the inverse function of this? Y equals to log 3x. So if you put it like this, 3 to the
3
power
to
y
the
equals
power
to
y is equal to x.
So y equals to 3x. Correct? This is the inverse function. So basically,
Yes.
whenever you have to plot the graph of y equals to this function, this is basically the inverse of the exponential function that you have read it. Okay. So if you have to plot the exponential function, how will you plot it? So if you have to plot this, so if you are tending x tends to 0, what is the value of y? If x is tending to 0, what is the value of y?
1.
1
Yeah, if x tends to 0, y is 1. And if x tends to, I told you in the last session, what did I say? How do you plot? Generally, you just need to get the criteria. If x tends to infinite or x tends to 0 or x tends to minus infinite, how did the plot, how did this, whatever the function has been given to be plotted, you just have to check it, this all condition, x equals to minus 0, so that you can get an idea about that. Okay. So if the x is 0, that means the value of the function is here, somewhere here. And if x tends to infinite, then y will also be infinite, correct? Correct or not?
0.
At x equals to 0, y you are getting 1, right? So this, okay, what? So this point 0 comma 1 will lie on this function for sure, right? If I'm just putting x equals to infinite, if I'm putting x equals to infinite, what will be the value of y? that will also be infinite, right? 3 to the power infinite is infinite.
Infinity, sir.
Correct? So now one point we got it, 0, 1. What the other point
Suppose sir
is?
e to power x.
Okay, and the other point is what? Okay, see, one more thing. Whenever you are just if you have been given a function, to get an idea about the function, okay, just to get an idea overview, how can you plot it? Never put any never put any random points. Okay, whatever you have told, okay, that will satisfy here, but do not put any random point, because you just put extreme points like 0, infinite, something like that, okay, just to get an idea about that. So whatever we are doing, like we just kept it 0, and then we are putting infinite, so the value was infinite. So there is something here, like infinite comma infinite, right? So this data something will go like this, right? And from here we don't have an idea. So what I can do is I can put x equals to what? What is the other point that I can put it to get the idea about the other part of the plot? What should I check? I check 0.
1, 0.
I checked 0. I checked infinite. What should the other value that I should be checking to get an idea about this plot?
Minus infinity.
Correct. So if I'm putting x equals to minus infinite, what should be the value of y? If I'm putting 3 to the power minus infinite, what should be the value? If I'm putting 3 equals to minus 1, what is the value of this 3 to the power minus 1? 1 upon 3.
Minus 3.
1/3.
If I'm putting infinite, if I'm multiplying this number infinite number of times, it will tend to what? 0 or infinite?
0.
Infinite.
0, right? Because this value is less than 1. If you are multiplying any less than 1 number to itself, infinite number of times, it will start declining, because you can see 1/3, it was 0.33. And then you have multiplied with 1 upon 3. Then you are left with what? 1 upon 9. This is even 0.1 thumb, less than this one. Correct? So it will start declining whenever you are multiplying a number that is smaller than 1 to itself, it will start declining. So whenever you are putting x equals to minus infinite, it will tend somewhere here, right? So you already know that at x equal to minus infinite, it will start tending to 0. So it will go something like this. It will never touch this, because you didn't got the exact point, right, where it will be 0. You just got that at minus infinite, the value will start tending to 0. But you didn't got that will be exactly 0. That point you didn't got. So you'll be just telling that this function will be something like this. Correct? Is it clear or not to everyone? Is this clear how to plot
Yes,
this one?
sir.
At least this exponential function. Okay. And if you have to get the, okay, so can you tell me whether this function, the exponential function, is a 1, 1 or not?
Can you please repeat, sir, one times? Actually, I have not understood.
Okay. I'll just repeat it again. So see, whenever you have to, okay, so basically we started with log equals to y equals to log x, okay, with the base 3. So we
Base 3
calculated
hypotenuse is x.
So we got the inverse function like this, correct? Y equals to 3x. Now I need to plot this. I need to basically plot this graph, but okay, I just started with this plot. And you already know that if you have a function, a plot, then you can take the image, okay, in the y equals to x axis, like the line parallel, like a line that is inclined to 45 degree, passing through 0, 0. And you can take the reflection of the other one to get the first one. This is what happened in the info function. So I started with plotting. How can I plot y equals to 3 to the power x? So basically we can check with 3 values, because every time we'll be able to get an idea about the plot. You should be checking with infinite, 0 or minus infinite. These are the 3 values that you should be checking to get the behavior of the function. Okay, I started with x equals to 0. At x equals to 0, tell me at x equals to 0, what is the value of y for this function?
X is equal to 0. Yes, sir. Y 1. 1, sir.
Y 1. At x equals to infinite, y equals to
0.
Infinite.
X equals to infinite, 3 to the power infinite. If you are multiplying 3 into 3 infinite number of times,
Yes. Infinity.
but infinity, right? So this is infinite.
Actually, sir, log
And if you
0
are
is
putting
undefined, no?
log
Log
0 is
0.
undefined, yeah. Yeah.
Log 1 is a 1.
Log 1 is 1, yeah. Log 1 is 0.
Yes, yes. Log 0. Yes.
Okay. So you started with this, and if you are putting x equals to
Actually, sir, calculator available logs function type.
it will be available.
Oh.
So what I'm just saying is, if you are putting x equals to minus infinite, you'll be getting y equals tends to 0, right? Right.
Yes.
So you can plot this function. Now you can plot it because you're already aware that at x, this is one point, this is the other point, infinite comma infinite. This is the 1.0 comma 1, and this is the other point, minus infinite comma 0. Okay, it will start something like this, it will go like this, right? This is 3 to the power x. Now I need to get this function. As this function was the inverse of this exponential function, what I should be doing is to just take the reflection of this function in y equals to x. If you are taking the reflection, what is the value you'll be getting? You'll be getting something like this, right?
Yes, reflection. Yes.
Correct?
Yes, yes.
So this will be equals to y equals to log 3x.
Yes, log 3x.
Now tell me which of the both, which one of the both are one function?
Why, sir? 1 function. Actually,
So both
this
are one functions.
vertical line is a one cut.
Vertical or horizontal?
Oh, yes, yes, horizontal.
Horizontal, sir.
Yeah, so both the function are inverse function. Inverse. I'm saying one function.
One function.
And both are inverse
Actually,
to
sir,
each other.
1 onto function check, then the horizontal, and the function check the vertical.
To check the function, you have to check it vertical line, and to check whether it's a 1 or not, horizontal.
Then
function,
horizontal.
horizontal line.
Okay.
Okay.
Suppose sir, x-axis upper than minimum value, and this type graph, this.
Okay.
Suppose sir, x
So
graph, sir.
see, again I'm saying it again and again.
Okay, sir.
And this I told you before also. You'll not be getting any excuse to, okay, you can calculate, but you'll not be getting any random equation that we'll be checking. Okay. So here, if I was just saying you why this
Actually,
both are
exam
one function.
most question this week 7 6.
Hey, why are you like now? You should not be thinking now from the quiz perspective. First, you just know all the concept. Okay. Well, last time also I told you the same thing, right? So did you find any difficult question apart from whatever we have discussed in the quiz paper?
No,
Okay, sir. Okay,
No,
sir.
right?
Sorry, sir.
No, it's fine. Whatever you're saying is totally fine. But what I'm saying is randomly, if you're saying something like some functions, so then it will be very difficult, right? So whatever we are discussing, why did we discuss one function is if you are getting this y equals to any exponential function, so you can just think of the exponential function. So what I was trying to say is, if you are having a one function, can you calculate the inverse of that function? This is what I was trying to say. Can you calculate, if you are getting one function, can you get the inverse of that function?
Yes, sir.
Yes, sir.
You can get it, right? Because we have seen that for the exponential function, we have calculated the inverse function, right? This is y equals to log 3x. And this is also a one function. So what is the what is the point that you want to conclude it? If you have a one function, so the inverse function also will be a one function, right? Or not?
Yes.
Correct?
Invert
Yeah.
function.
yes,
Yes,
sir.
1 function.
So from this criteria, whatever I told you, the basic criteria, I just am giving you some question. Try to solve that one. If you have a y equals to log a 1 minus x, where a, what are the criteria that will satisfy? What are the criteria for this equation, this question?
Base is a log.
A
Base
greater
is
than
a
0.
and hypotenuously 1 minus x.
Okay, so for what are the condition that should be applied
A
on the
greater than
base
0
first?
and 1
A
minus
should be greater than
and
0,
the one
A
minus
greater
x
than 0,
greater
A
is
less.
than
equals
0.
to 1. What is the condition that we'll be making here for this 1
greater
minus
than
x?
0. 1 minus x greater than 0.
Yes.
1 minus x greater than
Greater
0.
than 0.
X less than 1. Is it clear to everyone, this one?
Yes. Yes, sir.
Yes.
And if you have something like this, now tell me. What is the domain of this function? How will you start solving first? Tell me that.
1 to
Sir,
infinity.
actually 1 plus x, no sir. The 1 and the x is this side, minus 1.
The 1 to infinity, 1 not inclusive.
Yes.
What? One. You will start
X
solving
greater
at
than equal to 0. Less.
greater than 0, right?
And
Yes.
1 minus x are not equal to 0.
Yes.
How do you solve this
1
type of
minus
problem?
1 minus x, yes, not is equal to 0.
After getting 2, we will intercept.
And 1 plus x intercept.
Minus 1, 1.
Yes.
So for all these points, for all these data points or points, will this
Not
condition be
included.
satisfied?
Yes, sir.
No,
Yes.
sir.
This
No,
not
for all
satisfy.
these
Minus
data
1,
points.
1 satisfy.
Yeah, you just
Sir,
take some data
numeric-
point, minus 2. If you are putting minus 2 here, 1 plus minus 2 upon 1
numerator will
minus
become negative.
minus 2. What is the value you are getting? Positive or negative?
Yes,
What is the value you
yes.
are getting?
Negative, sir.
Negative, right? So this will not be satisfied. So
Negative, sir. Yes, sir.
this data point will not be
From
getting
minus
counted for
1.
this solution. Okay. So
Minus
basically we
1
are
to 1.
solving this equation. So we are solving this equation. So while solving this equation, you just put it on the straight line. You can just put it the data points with that will be the root, or you can say the zeros of this function. So minus 1 and 1, where the values are either root or the zeros of this function. And then we checked it from minus 1 to any data point, from minus infinite to minus 1. It will be same. The conditions, like if you are taking any data point from minus infinite to minus 1, it will be same. You can take it minus 3 also, minus 4 also. If you'll check it, the condition will be same for all those cases, right? Because there is no change, right? So all the things, all the characteristic of this function is changing at minus 1 or 1, because these are the roots and the zeros of this function, correct? So you can put it any values to just check it whether this is satisfying or not. You just check it, and like from minus infinite to minus 1, this is not satisfying, so these are not in the solution of this equation. Okay, now you are checking it from minus 1 to 1. If you are checking it, you are just put 0 here. If you are putting 0 here, 1 plus 0 upon 1 minus 0, so this is satisfied, right? So that means
Positive,
from
sir.
minus 1 to 1, all the data points will be satisfied, right? Because there is a change after 1 only. And after 1, if you are taking one value 2, you just put it here, 1 plus 2, 1 minus 2. So this is also not satisfying. That means this will also not be coming here. So 1 from infinite will not be coming. Minus infinite to minus 1 will not be coming. So what is the criteria? What is the value it should be taking is minus 1 to 1. Correct?
Yes, sir.
Yeah. So this is how you should be solving any. Like this is a pretty simple one, but yeah, this is how you solve. Is it clear to everyone? Is it clear to everyone?
Yes.
Yes, sir.
Basically, two things are there that you should be checking for any function log ax. X should be greater than 0, and this a should be greater than 0, or a should not be equals to 1. Okay, this is what you have to check every time.
We have not to check for the base. We have only checked for the x value domain.
But for base also they can give you, but yeah. So, but only for both you should be checking for both this values also and the base also. They can give you, right? They can give you something here also. They can give you something in the form of x, right? So you should be checking that condition of the x should be satisfied here also and here also. X, let's for example x plus 6 minus x square, some random values I'm just writing. So here also x should be greater than 0 and x should not be equals to 1. And then from here also you'll be getting some x condition. And then the intersection of all the three will be, the intersection will be your solution. Section of all the condition that you'll be getting for x will be your answer, final answer. Is it clear to everyone?
Yes, sir.
Yes, sir.
How will you
Yes,
plot
sir.
then? Okay, so ln x. Ln x is what? Your base is what?
B.
Right?
E, sir.
0. Oh, yes, sir. Yes.
Yeah. So how will you plot? What do you think? What should be the plot of this function? Ln x.
Just like this.
The similar to
What
whatever
this
we have plotted, right? Y equals to
Yes, sir.
log
Similar to
3x.
log.
Always similar. Yeah. So it will be also go like this. Correct?
Yes. Yes.
Not the
Yes.
same, exactly same, because the base here is different. Like e here is some 2.71, but the function, it will show similar to, the function will be similar to the log 3x or whatever we have plotted. Okay.
Yes.
What is the log? If I'm writing this is the mostly, the base will be 10.
10. Common
Yeah.
log.
Okay, so I'm just giving, okay. So in the logarithm function, only the most important part is you should be knowing the basic laws of the log function. Nothing else you should be knowing. Like this is the most important thing that you should be knowing. Okay, so can you tell me the criteria, the laws of this log function? And then we'll start solving the problem from the activity or practice. Okay, because there is not much to be discussed about the log function, only you should be discussing some problems. Okay, what are the laws? Can you tell me the first law, the basic law? Can we start with the basic? If you have a log am, what will the value of this?
Yeah.
M, right? If you have log a am, what should be the value here?
Yeah.
Log x, what should be the value?
1.
Log 1, what should be the value?
0.
0.
0, right? So this is the fourth basic one. Now log x mn, what should be the value here?
Mn
Log
minus x.
xm plus log xn.
Yeah, plus log xn.
Suppose, sir,
Similarly here
2
log
log.
x,
M
Sir, 2
minus.
log
yeah,
base is the
M
same.
minus log xn.
what should the value of log a 1 upon n?
Minus
Minus
log
log n.
an.
The value for this?
R log m.
R log base a to n.
This R is a multiple.
Okay. If you have something like this, log,
Suppose, sir, log a base is
what's the value?
Log x
log
base
is a
a.
common b minus x.
Log x, what
X
should be your
base
base?
a.
A or
A.
B? A or B?
A.
Yes, sir.
Yeah. This is clear to everyone?
Yes.
Okay. Can you solve this equation?
upon minus x square.
Okay, tell me, what can I write for this function? For this one, for the right hand side, what can I write? E to the power minus x square equals to what? What should I write? 2x minus 3. Can we write like this? Can you transform
Yes.
this as this?
Yes, sir.
Right?
Yes, sir.
Yes.
Now, how should I approach from here? Now you have read about the log function. How should I
Equating the
approach?
powers.
Take both sides
Okay,
of
how will you equate it?
Minus x square is equals to 2x
Sir,
minus
ln will
Yeah,
take ln
correct.
natural log.
Take ln on both the sides. If you are taking ln minus x square equals to ln. Now, what should be the value here? Now, can we equate it now? Minus
solve
x
quadratic.
square equals to 2, right? Can you do it? Now, can you solve it?
Yes, sir.
This is clear, right? This problem is clear to everyone?
Sir, I
Yeah.
have a question here. E raised to minus x square. Why we have not solved this as such means minus 2x? Why we have not did like this way?
Minus 2x where?
Here e raised to minus x square. There is
Correct.
right. Then why we have not solved this as a e raised to minus 2x, just like we have did in
Sir, she's saying about the
right hand side.
power function of log, the exponent function of log. Why we haven't used that? She's saying that.
Okay, here.
Yeah. She's confused between why we haven't used the power method here, like the exponent function of log.
So if you are taking log ln e to the power some p here, what can you write it for this function? P, right? Can you write it p here?
Yes.
Because ln base was e, right? And if you have something like this, you can write it here, right? So if you have ln, in spite of e, you have e, right? In spite of p, you have what? Minus x square, correct? So can you write it directly minus x square?
But minus x square will be minus 2x, right?
Minus 2x.
Yes.
How?
We should just like in the right hand side we did e raised to x square. It's not x square. Okay.
This is e to the power 2x, right? Upon e to the power 3. We just wrote it 2x minus 3.
Yeah, got it, sir.
Got it, right? Okay. Solve this problem. So whenever you are getting, so you can just, so how should I solve this? How should I start solving this problem?
Convert the 9 to the power x to the 3 to the power x to whole square.
We'll consider 3 to the power x as y.
Yeah, best part is you can consider 3 to the power x as some y. If they're
First, we
putting
have to
something like
convert
this,
it.
yeah, so
First,
can you write
we
it?
have to convert it in the 3 to the power x. All of these.
Correct. So whenever you are getting this type of problem, you can just start solving like this. Okay. And one more thing is, if you have 3 to the power x as y, what should be the value of 9 to the power x? Y square or not? Okay. So if you have, what is this 3 square and then x you have, right? This is what you have. Can you write it like 3 to the power 2x? Is this same to y
Yes,
square?
sir.
So you are left with what?
Yes,
Y
sir.
square minus 2 into y minus 27. Can you solve this problem now? And you can get the value of y. One more thing. Whenever you are solving this problem, like for example, we are solving this equation. And if you are getting the value of y something like this, right? What is the value? Minus b plus minus b square minus 4ac by 2a. What's the value of y here? 2 plus
9
minus
and minus 3.
4 minus
Sir,
4
it should
into
be, sir, b value should be 6.
okay, sorry. It will be 6. It will be 6 because this is what? 2 into 3x into 3, right? So it will be 6. Correct? And then you will be having this. So if you are solving this, I guess you'll get it something 9 and minus 3, right? From here you can see that 9 and minus 3. If you are getting y equals to 9 and minus 3. Now tell me what should be the exact solution for this problem. We have taken in the starting 3 to the power x as y, correct? This is what we took in the
Yes, sir.
starting. And now I am getting the y value as 9 and minus 3. What should be the exact value of x? Because we have to solve it for x, right? We don't have to solve it for y. We, for our convenience, we took it 3 to the power x as y. But in the end, you have to give the answer in the form of x only. So what will the value of x? And how many? Now tell me how many solutions are there? How many solutions are there for this equation? Number of solution. First tell me the number of solution.
Only one, sir.
Is it 1? Is it 2?
1.
Correct? How many of you are convinced with that? The solution, number of solution is 1. From here you are getting 2 values. Then why it is 1? The final exact solution, the number of solution, why is that the number is 1? Why isn't true?
Because as
Because it is
result
negative.
cannot be negative
Correct.
or
Because
positive.
to the power x, you can't equate it, it can't be negative, right? Because we already seen the plot, right? What was the plot for 3 to the power x? It went something like this, right? It can't be a negative value, right? So 3 to the power x can't be some negative value or minus 3. But it can be 3 to the power x can be equals to y, right? And x equals to 2. So the number of solution for this equation is 1 and the solution is 2. Is it clear to everyone or should I explain it again?
Sir, explain it again.
Okay. See, what did I say is, you have been given this type of problem. Now you can't solve this directly. Okay, for the convenience, what did I say? So for the convenience, we just took it 3 to the power x as y. So now what happened is 9 to the power x becomes y square and then this becomes 6y and then this is the problem. So this problem got converted here because we took it 3 to the power x as y for our convenience. Earlier it was very difficult to solve. So now we took it something like this. After solving, we got the value of y as 9 and minus 3. But one thing is that this is not our solution because this is the value of y. But we have to solve it for x. For our convenience, we took it 3 to the power x as y. So we will equate it this value. So whatever we have taken for our convenience, we'll equate it to that value. So 3 to the power x equals to 9. So x equals to 2. So this is the one solution that we got. Now the other solution is what? 2 to the power x equals to minus 3. But this can't happen, right? So if this can't happen, then we have only one solution and that solution is 2. Is it
Yes,
clear
sir.
now?
Yes, sir. It is clear now.
Okay. If that is clear, then solve this problem. Everybody. Okay. I'll just give this problem. So how many digits are there? So you have to find the number of digits for 15 to the power 7 square. Can you solve this problem?
No, sir. I don't know how to solve it.
Okay, any of you are knowing this? How to solve this? Okay, let's for example you have a to the power b. How can you get the number of digits? If you have 10 square, What is the number of digit here?
100.
3.
Sir,
3,
Oh,
right? So number of
digits, sir. Yes.
digit is 3, right?
Yes.
So how
Yes,
did you
sir.
solve? If you have been given this, if you have been given a problem like this, 10 to the power 10 ka square, so number of digit is what? 3. So if you have starting with 1, this is 10, this is 100, this is
sir, is there
1000.
8 digit in that question?
What?
Sir, the question you have given, is there 8 digit?
No, it's 49. Sorry, 49 plus 1. I guess this will be 50.
Okay, sir.
Not even 50, it will be more than that. If this was something like this, 10 to the power x
22,
square,
sir,
then you could
sir.
have told 20, 49 plus 1. But now here you have to solve it. You have to take the log here. Okay, I'll solve this problem. First, go through this one. So whenever you have a number between 1 to 10, and if you are taking the log, see, let's for example, you have a number 9. Correct? So what is the digit of this 9 number? 1, right? So if you are taking from 1 to 9, so you have basically only one digit, correct or not? If you have a number from 1 to 9, you have basically the digit. What's the number of count of digit? 1, right? If you are taking from 10 to 100, from basically from 10 to 99, you will be having 2 digits. From 100 to 999, you will be having 3 digits, correct or not?
Yes, sir.
Yeah. So, and then, so you just get an idea. So basically, log 1 is what? Log 1 is what? 0, right?
0. Yes.
What is log 10?
Log 10, I think decimal 1.
Log
0
10
point
is 1,
something.
right?
Yes, sir.
Log 100 is what? 2. You can get an idea, right?
Sir, just
3
I think
is
sir
4.
value रखना पड़ेगा.
Huh?
Value
Value क्यों?
just
No, you don't have to mug up, right? Log 100 you already know, right? Log of, if your base is 10, right? If your base 10, then 100 is 10 ka square, right? 10 ka square is what? 2 only. If you have log 10,000, that means log 10, 10 cube, right? So
suppose
3
sir
will go here, so it
log
will be 3.
log 90, sir.
That value you can't say, right? I'm just saying, hey, why do you ask all the extreme values? Like this, all values you can get. If you have been asked log 49, how can you say that? You can't say that, right? Exact value you can't say. But if it is lying between 10 to 100, okay, you can say that the values of log will be between 1 to 2. This you can say, right? This will be some 1 point some value.
I am
X, X, X.
just sir I am just guessing for the trigonometric and periodic table, just like value, just sine 90 degree, cos 40 degree, tan 94 degree, this type, no?
Sir, I think
No,
there
no.
is 50 digit in
No,
that
bro.
question.
No, whatever I am saying is totally different concept. I don't know what you are saying. But
That is
I'm just saying
explaining a
that,
concept,
see,
not giving us the value for to learn.
what?
I say that the sir is giving us
Actually
the
sir
concept of the log,
12th standard.
not give us the value to learn.
Okay,
See,
sir.
basically, we were solving this problem, right? To solve this problem, what did I say is, if you have any number, so this is the number basically you have been given. Okay, if you have been given some 1 to 10, any number, so you know that from 1 to 10, the number of digit of that value will be 1. From 10 to 100, the value will be 2. Basically, from 10 to
Okay,
99.
okay, okay,
Then
okay,
from
I have
100 to
understood.
10,000, 10,000 will be 3, 2, 3, and basically from 3,000, 10,000, 1,000 to 10,000 will be 4, right?
Yes, sir.
Okay. So what I was trying to say is, whenever you will take the log of all these values, whenever you're taking the log with base 10, so you can see that the values for this will be 0, for this will be 1, 2, 3, 4. And that generally, and that is what that is saying about your number of digits only. Okay. If you are getting any values between 100 to 1000, right? Basically, you are getting some 900. So what should be the value of log value? What should be the value of log here? If you are taking log of 900,
2 log 9.
2 log
9.
9, right? So it will be something 2 point some value, correct? Alpha, beta, gamma. It will be 2 point
Yes, sir.
something, right?
Less than
And
3.
whatever the value you are getting, basically this is what you are getting 2, right? And if you are just adding 2 plus 1, you'll be getting the number of digits. Correct or not? See, you are getting 9,000. 9,000, if you are getting the values, the log values will be from 3 to 4, correct? If you are taking log of this value, if you are taking log
Yes,
of
sir.
9,000,
Just like yes, sir. Just digit this
correct?
bit.
So it will be some 3 log 9. So it will be some 3 point something. So you just have to see
Yes.
this the leftmost corner, 3 value. So you just add 1. So the number of what? The number of digits will be 3 plus 1, 4. Correct?
Yes, sir.
Similarly, if you have a to the power b, now what will you do? What will be the number of digits? So you take log, right? Take log base 10. Whatever the values will be there, whatever the values you are getting, some, let's for example, you are getting k dot some value. So k plus 1 will be the digit, number of digits. Did you get the point? See, for this problem, what is the value? 15 to the power 49. Correct?
Yes, sir. Yes.
This is what you are getting, right? So if you are taking log, I told you to take the log value. You just have to take the log. If you are taking the log, what will be the value? 49 log 115. Correct?
Yes,
What is
sir.
the value of log 15? That you have to calculate it. What is the value you are getting? 49 multiply with that value, log 15. Okay. What is the value you are getting? You will be getting some number, right? Some in the decimal form, some k dot, maybe some values, maybe for 55, 57, some values you will be getting, right? After multiplying the log 15. Correct? And if you are
And
multiplying the log
calculator,
15,
sir.
you'll be getting k dot some values. And so whatever the value you are getting in the leftmost part, you just add it 1 here. Because, and the concept we got it, right? The concept, why did we add 1 here? Because you already aware of this, right? Whenever you are having a number between 100 to 1000, let's for example 900. So what is the value you'll be getting? So the value that you were getting is from 2 to 3. So any number between 2 to 3, the log value of 900. Okay, 2 point some values, right? 80, 90, some values you'll be getting. So 2 plus 1 was the number of digits that basically we were getting from the starting. So here also, whenever you're solving this, of taking the value, the log of that value, k dot something, so just add it 1 in the leftmost part. Whatever the decimal, the number that you're getting part in the leftmost part, you just add it 1 here, you'll be getting the number of digits there. Is it fine to everyone or not?
Sir, is this applicable
Sir,
only log to the base 10 or we can apply log to the base 8?
No, log 10, take 10 now. You can do for the other cases also, but again you need to check it, right? For the log 10, we were already aware, right? So this method, for this is 0, this is 1, and then for the other case, if you are taking whatever the number you are getting, let's for example a you are taking. So here it should be a square, right? Here it should be, so this is 1. Okay, so here it will be 1, then 0, then 2. So here you have to take it aq, a4, right? If you are taking base as a is some random number. So we were taking 10, right? So this is 10, this is 100, this is 1000, this is 10,000. Okay. So here it was pretty much clear for us. So we got an idea. But if you want to take it A, you can do it with that method also, but that will be hectic. Is it clear now?
Yes, sir.
Yeah. So let's start with the activity problem. Okay. So tell me the activity problem. Which one you have a doubt? Did you solve that all the activity problems or not?
Sir, I have doubt in 6.2 question
Yes,
number
sir,
3.
but the questions are tough.
Okay, 6.2, right? 6.1, nobody has a doubt, right?
Sir, I
Like
have a doubt in question number 1. 6.1.
Okay, 6.1, question number 1.
1, 3, 4, 5, sir. I have a doubt.
1, 3, 4, 5.
So,
Okay.
so
So the first
total
question,
how
what is the
There is
first
questions?
only
question?
3 days for week 6 credit assignment.
What?
Sir, why there is only 3 days for week 6 credit assignment? The deadline of week 5 is I think, 5th November, and the deadline of week
Because
6 is
week 5 was extended.
Because
So
the deadline for week 5 was extended. The deadline for week 5 was before quiz itself. Okay. So we have
okay,
extended
sir.
because we thought many of you would not solve that. So that's why this
Okay,
is the
sir.
original deadline for week 6.
Okay, sir.
Yeah. Okay. So let's start with the first question. What is the first question? The first question is, for which data point, for each point on the Cartesian point, will the equation x equals to log 2y equals to log 0.2y be valid? Out of the 4 options, 1, 1, 0, 1, 2, 1, 0, 2. Which the following is, this is pretty simple, right? Is that if you are putting the value of 1 here, what is the value of x? Whoever has
0.
asked the question, can you tell me? If you are putting the value of y as 1, what will the value of x? 0, right? So the second option is correct. You can't get it 1,
Okay,
1,
sir.
right? You can't get
Okay,
it this also, you can't get this also. What is the next question?
Sir, 6.2 question number 3.
No, first from 6.1 and then we'll move it. 6.1,
Okay.
anybody has any doubt in this?
Question number 3, sir.
Question number 3. What is that question number 3? Okay, so basically you have some function log 10, then log 10x whole square minus 8 log 10x plus 15. This is
The
the function
answer
f.
to the before question would be 0, 1, right? The previous question.
Yeah, it will be 0, 1. Yeah.
Like you have crossed it, so
0,
I was confused. Yeah.
No, I just checked. The second one is correct. The other one is incorrect. Now, how will you solve this problem? What did I say? I told you 2 things, right? I told you if you have been given log x, just check for a. For a, so it's already been done. You just check it for this. For x, you have to check it. Correct? This will be what? This will be greater than what? This will be greater than 0. Correct?
Yes, sir.
Yeah. Just
Sir,
take it for the convenience. You can take it like this: y square minus 8y
Okay.
plus 50
Okay, sir.
greater than 0. Just check it what the value of y you are getting, and then put it here to get the condition. Okay.
Okay, sir.
Yeah. Any other question from 6.1?
Yeah.
Can you please explain this question again?
Yeah. See, you have been given this problem. Log 10 ke andar something you have been given. Now, how can you? I told you for any function of log, been given something like this. Just check for the all the condition for base and all the condition for this domain. Okay, for the base, it's already been given that it's a positive number 10. So this is fine. For a, we don't have to check it. For x only, we have to check it. So this value will be greater than 0. Okay, for your convenience, you can take log 10x as y and then solve this problem. You'll be getting some values y, right? And then put it here. You'll get it the value of in the form of
Sir,
x.
how to find the domain, sir?
So domain only we are finding, right?
How it is?
See, domain is what? What is, first tell me what is domain?
Input value.
What is the domain? Input?
Valid input values.
Correct. So input okay, valid input. So this is what I was saying. For any function log x, what is the input that you should be putting for this function? Can you put it -5?
No, sir.
You can't put it. So this is what I was saying. For a should be greater than 0 and a should not be equals to 1. And this x should be greater than 0. This is what the domain is. So the domain for this function is x greater than 0.
Yes,
Okay,
sir.
and if you have been asked for the condition of a also, so a also you can tell, right? So this is the domain. This is how you solve the domain. You just have to check for whatever the condition, this function is satisfied. The function is valid. So this function was valid for what? This function was valid when this was greater than 0. Because the base is perfectly fine. Base you don't have to check. So what is left is the inner part. So this should be greater than 0. And how will you do that? You just, for the convenience sake, you can take it log 10x as y. Put it there, solve this equation, get the value of y, put it here to get the value of x. This is how you solve the for any domain function. So you just have to check what are the conditions where the function is valid. Okay, what are the valid point that you can put it? Okay, and this starts from here itself, log ax. X should be greater than 0. This is the only condition that you have to check in
Okay,
log.
sir.
That's it. Yeah.
So, but we get y values y greater than 3 and y greater than 5, sir.
What?
We get y greater than 3 and y greater than 5. So we should take only
Yes.
y greater than 3.
Y greater than 3 and y greater than 5 you are getting.
Yeah.
I don't think so you'll be getting this value for sure. If you're solving this equation, you have 1 is 3, 1 is 5. So if you're putting 0 here, this is satisfied. So this will not be satisfied. This will be satisfied. Okay. So minus this, the solution of y will be y equals belongs to 0 to inside minus infinite to 3 union 5 to infinite. Okay, and as you already know that log, it was log 10x equals to y, so that y can't be less than 0, so it will be 0 to 3 union 5 to infinite. Okay, and then you can put it here if you are putting the value of y, and so basically no, what you can do it here is you got the value of y, right? If you are getting the value of y, you have to convert it in the form of log 10x. Okay, form you have to change it. So you have to get it with 5 to get the value of x basically, because the answer that has been asked in the form of x, not in the form of y. But you already know that this is a condition that has been satisfied for y. You can put the value of y here. So what is the value of x you'll be getting if you are putting y equals to minus infinite? What is the value of x you'll be getting? 10 to the power y equals to x. Correct? What is the value if you are putting minus infinite here? We'll be getting 0 here. Correct or not?
Yes, sir.
Yes, sir.
You're able to understand. Okay, I thought, okay. So similarly, this is the value 10 to the power 10y. Put the value of y here, 10 cube. So x is this one. So the value of x is lying from 0 to 10 cube. Union, again you have to put it here 5, 10 to the power 5 and infinite. If you are putting 10 to the power infinite, it will be infinite only. So this is the value. The answer should be. Is this clear?
Yes, I got it.
Yes, sir.
Yeah. Next question. What is the next question? Can we move to 6.2 now?
I have a doubt in question number 5, sir.
Okay. Question number 5.
Sir,
What
can
is
you
that
please
question?
share the question screen, sir?
Scroll up.
Or sir, the portal question, sir, because in my laptop portal is not open.
This the yeah. So question number which one? Yeah, this one only, the fifth one, right?
Yes, sir.
Yeah. So what is the domain? Again, the same thing you have to do. Let's solve this one. Basically, this value should be greater than 0, correct? If this value is greater than 0, so I can't write it here, but okay. Yeah, I can again have to go there. So the function is, where the function is log minus x e3x 27x, correct? Okay, now you will solve. What did I say? For any log function ax, what is the condition that you have to check? You have to check for a and you have to check for x.
Yes,
A
sir.
is already perfectly fine because the base is 10. You have to check for
10,
x.
yes, sir.
So this value should be greater than 0 or not?
Greater than 0.
Greater than 0, sir.
Okay,
Greater
if this
than
is greater than 0, you are multiplying with minus. So this value x ex minus 27x should be greater than or less than 0?
Greater.
Less than
Less
0.
than, sir,
Greater than 0.
because there is
Less than
negative
0.
sign in.
Less than
Negative
0.
would be change the inequality.
Correct. So now come again here. So you have left with what? You can take the common x, right? Can you take x common? It was 3x minus 27 less than 0. Can you get the solution for this? There is one change. What are the changes? Where is the change will happen? X equals to 0. And the other, what is the change? Where? It was 3x equals to 27. This is the change. This is the point where the function's characteristic will change, right? This is how you solve. X equals to 0, and then the point where the e to the power 3x equals to 27. What is the solution for this equation? Tell me fast.
X equal to 1.
No, 3x.
3x actually, sir, 3 base multiply, no, sir?
ln e to the power
No,
3x
no.
It
equal
will
to
not be the direct number. It will be in the form of log. Why did you learn log then? If you are just dying, how can you say directly e to the power
Okay.
27? What is then?
ln 20
what is the
ln 27 by 3, I guess.
Yeah. So how can you start? Just start thinking. How will you start? For if you have to get the solution for this equation, how will you start? You have to take the concept. Yeah. Apply first of all. Apply ln. Why will you apply ln? Because you can see the e here. So you should be applying log with base e only, right? So it will
Yes,
be 3x ln e equals to, this will be what? This is what 3q, right?
LN.
ln 3q. Correct. Ln e is what?
1.
Right? So 3x equals to
LN of
3q. 3q ln if you are taking, so you can just write it like this: 3 ln 3, right? 3x equals to 3 ln 3. 3 will get cancelled. So what is the value of x? ln 3, right? So this is the point. So the point, the where the characteristic of this function will change is 0 and ln 3.
Yes, sir.
Correct or not?
Yes, sir.
Okay. So this condition, you can put it any value, -1 or anything. You will see that this will not satisfy, and this will also not satisfy. So the condition that will satisfy is from 0 to ln 3. So the answer should be x belongs to 0 to ln 3. Okay, this will be the domain for this function. Did you get the idea? How do you solve the domain?
Yes, sir.
Any issue? Anyone?
No, sir.
Can we move to 6.2 now?
yes, sir.
Yes, sir.
Yeah, I'll just take 1 minute break. I'll just bring my water. Okay. So let's start. 6.2, which question? Question number? Can you hear me?
Hello.
Yeah, can you hear me?
Yes.
Yes, sir, you're audible.
Okay, let's start then. 6.2, which question you want me to solve?
So question number 3.
Okay. So 6.2, the question number is this one. Log of 2 x. Okay.
Sir, I have problem in option 4. How to check option 4?
Okay, a straight line x equals to 8 is an asymptote of this function. What do you mean by asymptote of a function?
Where the value of log tends to 0.
Okay.
Tends to infinity. It doesn't touch the curve, but it appears to touch the curve at infinity.
Yes, sir. Yes, sir.
Basically, asymptote is a line of a graph, a line that a graph of a function approaches as either x or y. Let's, for example, this can be the asymptote, right? If you have function, this is one function. So here, x coordinate, y both can work as asymptote for this function or not.
Yes, but how I check this 8 is option 4 is not correct?
Okay, let's come again here. If you are putting x equals to 8 in this function, what is the value you are getting?
3. First.
Log 2, 3 you are getting, correct?
Yes.
So you're able to get a value, correct?
So how to find the inverse of this function?
What do you find? How to find?
Inverse of this function.
Inverse, it's like you can find it, but why do you want to find? If this is a 1-1 function, you can say directly, right? If you have if any function 1-1, then you can say that, right? Inverse of this function will occur.
Yes. Yes, sir.
Right? So this function is a 1-1, then you can directly say it's an inverse function, correct?
Yes, sir.
So the inverse of this function will occur. See, and regarding the asymptote, for any function, what did I say? If you have any function, like this was a function, this was a function. Let's, for example, this is a function. Asymptote is this one, correct?
Yes, sir.
What is this function? This straight line. What is this straight line?
Y is equal to 0.
Y equals to 0. Okay. So will this function, this function will meet this asymptote at any point?
No, sir. It approaches.
It approaches, right?
Yes, sir.
And this was the function. Can you tell me the plot of this function y equals to?
E to the power a to the power minus x.
A to the power minus x.
Yes, sir. A to the power x, where a is between 0 and 1.
Correct. Where a is between 0 to 1. Right?
Yes, sir.
Can you get the value of x where y is equals to 0?
No, sir.
No.
No, sir.
You can't get. But here in our question, what is the problem? In the question, here it has been given the straight line x equals to 8. X equals to 8 in this problem, log 2, 2, 2, x you're putting. What is the value you are getting?
Log 2,
If this,
3.
you are getting some value basically.
Yes, sir.
So how can this be asymptote? It can't be.
Yeah.
Correct?
Yes, sir. Yes, sir. I got it, sir.
Yeah. 6.2. Anyone has any issue in 6.2?
Sir, excuse me, sir. Sir,
Yeah.
one dot. Suppose, sir, ln of sin x value.
Sin x have you read?
Sir, sin x.
Sin x is taught, right?
This lecture, sir.
No, sir.
No, sir.
Not taught. Okay.
In general, sir, suppose.
Ln of sin
x.
Correct.
Find the value, sir.
Yes.
Value, sir. Value.
Value of what?
Logarithmic value, sir.
For
ln
what?
of, sir. Actually, one upon sin x into cos x, no? Cot x. This value. Derivative, sir.
Derivative is not been taught yet. Why are you asking? I don't understand this. So basically, if you have been given the function, what do you want me to do? Like the derivative or what?
Okay,
Derivative,
okay, sir. Only for domain and range. Actually, I have lecture not gone, sir. Sorry, sir.
But like, see, it's like you can ask anything here, but that won't be appropriate for the other people, right? Okay. What is the value of sin x? Plot of sin x.
Graph, sir.
You want me to calculate the domain, right?
Yes, graph axis of x-axis -1, 7.
Something like this, right?
Yes.
So which of the values that ln will take?
This sin x.
0 only.
Yes,
Positive
greater
value.
than
0, right? So all the
Yes.
values wherever the greater is wherever the x value is, wherever the y is greater than 0, right?
Above x.
Y equals to sin x. Let's, for example, this is the equation. So all from here 0 to pi, and then from here to here, here to here. So all these values it will take. Other values it will not be taking because you already know that. So again the same thing. You have to solve for sin x greater than 0, right? So you have to take it all those values of x where the sin x is greater than 0. This is what you have to do, right? For the domain or any function. Correct?
Okay, sir.
So you'll be getting a periodic function, and that will start from
periodic
0 to.
function.
Okay, but it's not like if somebody is not able to understand, it's totally fine. Okay, let's move to 6.3. You have any doubt in 6.3?
In activity 6.2, number first question.
6.3.
2, sir.
6.2 first question. Okay.
Sir, can you repeat how to solve log 2 into log 2 in 8? That previous question.
Log 2 into log 2 into log 2 x. Okay, if you have to get 1 function, is this a 1 function? If you are putting the value of x1 equals to some random value, so what is the things that you basically check for for a 1 function? To check for a 1 function, what is the condition that
Its
you basically
base
check?
is greater than 1.
If x1 is greater than x2, fx1 is greater than fx2, or you check it whether this function is strictly increasing or not. This is what you check, correct? And this is a strictly increasing function, right? So if we have a strictly increasing function, that means the function will always be 1 function. I told you in the starting. Okay, so this is a 1 function. The other condition is to check is whether if this is a 1 function, then for sure you'll be having a inverse of that function. Inverse will exist for any 1 function. This is what we have discussed for this function. Okay.
Okay.
Sir, inverse means reverse function, right?
Yeah, ulta.
Oh, yes, got it.
Basically, so if you have 3 to the power x, what is the inverse of this function?
One by three.
Log 3x. Okay.
Okay.
Not 1 by 3. 1 by 3. So that is not an inverse function. How do you calculate inverse function? Basically, you just write it y equals to 3 to the power x. Okay, take log both the side. X ln 3. Or basically, you start from here. 3x. If you have to calculate inverse, how will you calculate the inverse for this function?
3 power x.
This is y, right? Basically, this will go here, right? 3 to the power 4. 3 to the power y will be equals to x. This is how it goes, correct? And then you interchange the value of x and y. So 3 to the power x equals to y. So the inverse of this function is this one. So this is what we have told. And to calculate the graph of an inverse function, take the reflection in y equals to x. So whatever the plot it is there, you just take the reflection, okay, in y equals to x function, you'll be getting the exact. So for what is the plot of y equals to 3x?
Sir, the log 2 log 2 8, you said it is 1 1 because a log 2 8 will be greater than log 2 7.
Log 2 log 2?
Log 2
No,
log
for
2.
yeah.
You said
Log
it is
2
1 1
log 2.
because
Let's for example, this is a function.
x1 has to be greater than x2. So in this case, log 2 8 will be greater than log 2 7.
Yeah, if you are taking any values, not only 8 and 7, any values.
Yeah,
If
I understood. Any values?
x1 is greater than x2, the function fx1 will be greater than x2. If this is not occurring, then it's not a one function. Sorry. No. Yeah, you can check it. Why we are checking this? Do you know why we are checking this? Because from here you can get an idea that's whether this function is increasing or not. If this is occurring, then you can say that it's an increasing function. And if it's an increasing function, strictly increasing basically, because we are not taking it greater than equals to anything. So if it's a strictly increasing, you can directly say that this is a 1 1 function. But you have to check it for 1 1 function. Yeah. So this is the method that you basically check it for 1 1.
Okay. Sir.
Okay. Yeah.
Excuse me, sir.
Yeah.
Hello.
Yeah.
Sir,
Yeah,
log b, sir, log b upon x upon y value, sir, formula.
What log b?
Log x upon y base is a b. X upon y. Yeah, base is a b.
What do you
So
write
value,
for this?
formula, sir, value, suppose, sir, this, then, sir, negative value, no?
Negative value? Why negative value?
Actually log x b minus log y b. Actually base both same.
तो log b x minus log b y.
Oh, just a base same, then this formula use. Okay, sir.
Clear, right?
Yes.
This is the properties of log function, right?
Yeah, this is a basic properties of the
Yes,
logarithm.
basic property.
So can you please show the base change property? I got stuck in the base change.
Okay. You have something like log x. What can you do is, can you write it like this? Log x upon log a. And you just take the new base.
We can take any basis.
Any base, any number you can take. Yeah, according to your convenience, you can take any number.
Sir, take an example on this question.
Example. Okay, you just tell me any values. Log This
3
is
to the power x.
100. This is 10,000. Okay, and you have to check it. Log of 10,000 upon log of 100. We are taking the base as 10 and 10 here. From here, what is the
Generally,
value
we
you are getting?
can take the base 10.
Yeah. So what is the value you are taking here? What is the exact value you will be getting here? 2, right? This is 2. And from here also, what is the value you will be getting? 4 upon 2. So you'll be left with 2. Correct?
Yes.
Yeah. Okay. Is it clear? Yeah. So let's come to the first question. The first question somebody asked, 3.8
Sir,
cube,
can you please show
6.2.
Yes, sir.
Okay. So what is the question here? The function is fx equals to log 2x. And what is gx here? Log 2x minus 1. Okay, first tell me what is the abscissa and what is the ordinate. First tell me what is abscissa and what is ordinate.
Ordinates is y-axis and abscissa x-axis.
Correct. So ordinate is y-axis and abscissa is x-axis. So now tell me the domain for this function. What is the domain for this function? X greater than?
X greater than 0.
What is the domain for this function?
X greater than
X
1.
greater than 1.
X greater than 1. If you are plotting for gx, this is 1. For gx, this is the domain for gx. But for fx, this is the domain from g, right? From this is for fx.
Yes, sir.
So which of the following option is correct? The abscissa for gx will be 1 greater than the abscissa for fx, right? So the abscissa, so the x coordinate of gx will be always 1 greater than the x coordinate of fx.
Okay,
Is it
sir.
clear?
Yes.
Let's move to the other 6.3. Anybody has any doubt? 3.6.3.
I have a doubt in question number 2, sir.
Question number 2. Okay. What is that question? You have a function what? ln x minus e to the power minus x. Can somebody tell me whether this function is 1, 1 or not?
So how can you find that the 1, 1 or
It
not?
is not a 1-1 function.
No, get an idea about that one. Increasing or decreasing function, at least. If you are writing ln,
It's not
Increasing
1.
function, sir.
maybe what?
1 upon e raised to x.
Hmm.
And if we are multiplying e raised to x, go that side, then it will be x e raised to 2. It's a e raised to x square, right?
It about 2x.
Okay, x square.
So it wouldn't be 2x.
What?
So after this, how do you check it is increasing or decreasing?
No, I'm asking how will you approach from here? Okay, so somebody is saying this and then she didn't. Okay. How will you approach for this question?
Can we do it by the putting the infinity to the value of x? From the infinity to
What?
where the y is going.
Correct.
If we put
Can you get the
x to infinity, then we
if you are putting the value of x tends to infinite,
positive infinity.
what is the value of y?
Infinite.
So basically, if you are putting at infinite, minus e power minus infinite, right? So this will be tends to 0. So you'll be left with infinite, correct? So
Yes,
y will tends to infinite, correct?
Yes. Yes, sir.
What is the other condition that you should be checking?
Minus infinite x to the x tend to minus infinite.
X tends to x. If you are putting x tends to minus infinite, then it will be a negative number. Negative number can't have like occur bit inside ln, right?
Yes, sir.
Correct. That will not be a
That
case.
is
So
not
we
defined.
can check it, yeah, but it will not be satisfied. What are the other things? Can you check it with x equals to 0?
Yes,
For
sir.
x equals to 0, what is the value you are getting?
Yes, sir. E power 0 minus e power 0, which is 0.
Defined.
ln 0. ln 0 you already know, right?
Yes,
So
not
whenever you were
Not
approaching
defined.
for any condition, it was going something like this, right? At 0. So this will be similar to that function. It will go something like this. So at 0, you already aware that it's not defined, and it was you already know that it will go something like this. And at infinite, so it will go like this. This is the function ln e to power x minus e to power minus x. Is it an increasing or a decreasing function? If you are increasing the value of x, whether the y value is increasing or not?
Increasing, sir.
Increasing, right? Or from the graph itself, can you say directly it's a 1 1 or not? Can you check with the horizontal line?
Yes, sir. 1.
Yes, sir. 1 1, sir.
1 1.
Sir, in this,
Can
if
you
you
calculate the
So
put,
we
inverse for
can
this
do it
function?
easily by inverse will be exponential. The reflection.
It's an increasing function, 1 1 function, increasing function. Can you calculate the inverse for this function?
sir, you said when you apply minus infinity to this equation, e to the power minus infinity will go towards 0, but then we'll have minus e to the power infinity, which will take it to a negative value. Is that what you said?
Correct. Yeah. So e to the power minus infinity minus e to the power infinity. Correct.
Yes.
So this
And
will
that,
tend to 0. So 0 minus some larger number will be a negative value. So ln can't take that, right? So that's
so
why
this
you should not be taking
establishes that, yes, sir.
what? Yeah.
This
So
establishes that it's an increasing function.
but no, that also establishing that thing, or from there also you can get an idea, right? It's behaving similar to ln x, right? So it is going something like this. So it's increasing function. At infinity, it was
Reflection is
behaving
also 1
at infinity it was infinity, but at 0 it is some undefined, or you can say
But
that's
sir, the
like
domain we can't go to minus infinity, right? Like the values, it's only defined on the positive x.
so this is what we are doing, right? It's defined on, so this is the plot, x is here, y is here, and we are going something like this, right?
Yes, sir. So this is not defined for negative x, right? And negative infinity lies in the negative x side. So
So we
why
are
are we
not
even
taking
checking?
care of this, right? We are not dealing with these cases because we are already aware that x tends to minus infinite, ln is not behaving, right? And ln doesn't behave
ln will be a
when
negative value, and for that negative value, ln is never defined. That's the
never
logic we
defined.
apply, right?
Yeah.
Okay.
That's
And
why
then,
we will not see. Basically, we are just have to. We can't get the exact figure, but we can get an idea about the figure, the plot.
So the conditions we check to understand whether the function is increasing is first letting x tend to infinity, seeing how y react, and then let x tend to 0 and see how y react.
Extends to minus infinite also. But in this case, minus infinite was not giving us any condition. But for the other cases, it will give you an idea.
Okay, so that is why we did x tend into 0. Like what happens when x tends to 0? How does the graph react? Okay,
Yeah, yeah.
okay, right.
Okay. Any other problem from 6.3?
Sir,
So this is
first
how basically you
question.
check. Yeah, this is basically how you check for one function. There won't be any difficult function that will be given. Just the whatever the function has been discussed in the lectures or in there in the graded. I don't think so. Anything apart from there will be asked in the paper. The question of first. Which one you are asking?
First question, sir.
Okay. What is the first question? The domain of a function has been given. So you have been asked to calculate the domain of f of ln x. How will you calculate this? How will you calculate this?
Sir, -3 will not be considered as ln of x should be greater than 0. So it will be 0 to 1.
Why?
F of x equal to, means domain of f of x is -3, 1. And ln of x is not, means it should be greater than 0. So we will not consider -3 to 0 value. We will consider 0 to 1 value only.
No, you just have to equate it where ln x is equals to -3 and ln x is equals to 1. What is the value you are getting from here?
But ln x will not be minus
Sorry.
negative value,
Yeah.
right?
Yeah, it will not be negative value. Correct.
Sir, x in ln x cannot be negative. Ln x, the range is real numbers.
Yeah,
right?
yeah. Correct. Yeah. See, this number I got. So this value can't be negative, but this value
The whole
overall
thing
can be
can be-
negative, right?
Yes, sir.
See, x value can't be negative, but if you are putting some values from 0 to 1, this value overall value will be negative, right? Or maybe you're just putting the value of, if you have ln x, if you are putting some 0.5, 0.6, you'll be getting some negative value. Correct? So you can, when you were having this plot, I told you, see, the domain can't be negative, but the y range can be negative, right? So the y, you can see that y can be from minus infinite to infinite. That's why the range is r. The domain is only x greater than 0, right? So this will be equals to, it can be -3. Is this clear to everyone? This is what you have to do.
Yes,
Is
sir.
just equate it to ln x equals to -3, ln x equals to 1. So you are getting what is the value of x? -3 and x equals to e to the power 1. So this should be the domain, -3 to -1. Okay?
Okay, sir.
Yeah. Any other problem from 6.3? Any other problem from 6.3? Nothing, right? 6.4, can we move to 6.4?
Yes, sir.
Yes, sir.
Yeah, 6.4, tell me.
Sir, like I haven't, like the question that we discussed about e to the power x minus e to the power minus x, as x tends to infinity, x tends to 0,
Yeah.
like e to the power x tends to negative infinity, right?
At x equals to
At x,
0.
as x tends to 0.
Yeah. At x equals 0, ln will tends to 0 minus 0, some undefined value. And you already know that while plotting the value also you are knowing that, right? As the x was approaching to 0, this function was something like this, right?
E to the power x minus e to the power minus x.
Okay, if you are getting
Minus
confused, you
1
can just
minus
take the
1 is
value of
0.
some other number. 1, you can take 1, e to the power 1 and e to the power minus 1. It will be ln e to the power 1. Correct? This value you can check it like e to the power 1 minus 1 upon e. This will be a smaller, very small number. So ln e is sum. What is the value of if the x is 1 somewhere here? So y is here. What should the value of y? If the x
ln
is
e
1,
is
then it
1,
will be
right?
somewhere. You can check
ln
it something like this. See, ln e is 1.
is 1.
Okay, so at infinite, you already know that it was infinite. So now you can check it
Yes,
for,
sir.
if you are getting confused for 0, you can take it for the other values. Other values can be ln e. Let's, for example, ln e is the number. Okay, so you can check it. What is the e to the power x, huh? Or what was that
E to
value?
the power
It was
x
minus
minus e
x.
to the power minus x. Yes.
Hmm.
So
So
we check for x equal to 1.
x
So it
equals to,
becomes
it will be e1
1,
minus e power minus
1
1.
by e.
It will be some positive number, correct?
Yes, sir.
It will be some positive number. It will be some 2.7 minus some value. So okay, then you have to check it with the calculator whether the number will be positive or negative.
Okay. And from that we get the idea that this is
Like the plot will go somewhere like this, right? So only the idea you have to get it, okay? Or you can just, if you are getting confused with those things also, you just take two random values, okay? Check whether this function is increasing or decreasing. There also, if you are getting confused, calculate the derivative. Because derivatives has not been taught, so this method is like neglected. But the other method is like you can just take two values. From here also itself, you can see that at x equals to infinite, it was infinite. At x equals to some 1 or something, so the values has declined a lot. Okay, so it will be some sort of increasing function. Okay, if it's an increasing function, you can say it's a 1 also.
Generally, when
we
we
can
need to
also
say it,
do
we need
it
to come up with a value that is sort of negative, right? So that we can solidify that, okay, this is increasing or decreasing. Like a value of x that will give us a overall total value that is like negative, so that we can confirm, okay, this is as.
See this function now, ln is about x minus to the power minus x. Whenever you'll be increasing the value of x, right? You can see that whenever you are increasing the value of x, this value to pakka will increase, but this value will not increase much. Correct? Because
It
this is
actually
getting
reduces. The first
multiplied
one
that number
increases
of times, so this
exponentially.
will start decline. Yeah, but this will not increase, right? This will decrease or whatever. It will not be increasing for sure, because this is getting multiplied that many of times, so it will start declining because you have 1 upon 2, and if you are multiplying 1 upon 2 again, it will start declining. So this will decline. So this overall value will be greater than that. It will start increasing if you are increasing the value of x. So from here also you can get an idea that it's an increasing function. Correct?
Yes,
And by
sir.
establishing that it is an increasing function, we can say it is 1 to 1 as well. Right?
Yeah, you can directly say it's a 1 function.
Okay, thank you.
Sir, if the function is increasing, then it is 1 to 1, or?
Yeah, this is a 1 to 1, strictly increasing. Yeah.
Okay.
Any problem in 6.4?
While the function is decreasing, it is also one
For
function.
decreasing function also, yeah, for anything, it should
Yes,
not
sir.
be, it should not be decreasing and increasing both, either decreasing or increasing. It should not be both. See this function,
Yes,
it
sir.
was going somewhere like this. Even though this function is going some like this is also a 1 function, because it will also satisfy all the horizontal conditions. Correct? So whether it's a increasing or decreasing, only you have to check whether the function is a, it should be one of the two. It can't be both. right? Like this.
Sir, even for x cube, it is possible. So x cube.
For x cube, how will you plot the function?
So we can do it also by in the lecture the sir has wrote that if the base is greater than 1 then f is increasing, and if the base is greater than 0 and less than 1 then the f is decreasing, function is decreasing.
That also you can do. Okay, any method you can apply.
Yes,
Anything you can apply to get an idea.
So just by saying that e is a number that is greater than 1, and generally a greater than 1 in a to the power x tends to give us increasing values, strictly increasing graphs. Can we say it that way?
Okay, can you repeat it?
For a to the power x, if a is greater than 1, it is an increasing function.
Correct.
A greater than 1, no, not 0. A greater than 1. And given in this question, if we are given e to the power x and e is greater than 1, it's an increasing function. Can we say it that way?
You can say in that way, yeah.
Okay.
But this equation was simple. If you are getting some where the plot will start changing, I guess. See, this problem was pretty simple. They got directly about x. But if you are getting some polynomial, then I guess you'll have to check it with the plot only.
By inserting values like we did, right, sir?
Yeah.
Okay.
So the best method is to get an idea about the graph only. And if nothing has been given, some simple function has been given, e to power x minus e minus x, so directly you can say. But if the polynomial has been given, you have to do something else also.
Maybe convert it into like forms where we can get the roots and like all those, like if it's.
But I see, let's for example, you are taking any polynomial x cube plus 2x plus 3.
Yes, sir.
This is so directly you can say it's an increasing function because all the values are positive.
Yes, sir.
Yes, sir.
This too you can't say there is no problem in that. You can directly plot it. It will go something like this. Somewhere it will go like this. Okay.
But sir,
But
sometimes when we when we find its root and then its factor, it can give us like x minus 3 into x plus 2, in which case we
that's
have
for
two
example,
roots.
yeah.
In
Correct.
which case it's not
This
increasing
equation,
or decreasing, right?
this function is not even, I guess, decreasing but not increasing. This you can't do, I guess.
So even if a
Because
polynomial is given, we have to always check that, right? Like whether
yeah,
we
for
get the
this
roots.
polynomial you have to check it, right? Because I don't think so it will be that simple. It will go somewhere like this.
In which case it's not increasing and decreasing.
Yeah. Okay. So if you have a polynomial, if the simple things has been given, you can directly say. But this type of plot, because you can see that the values, if you are changing the value of x from here to here, you can check it. The values started increasing and then started declining because of the condition, because of this polynomial itself. And ln is what? See, so the best part is about the ln is ln itself is an increasing function. Okay, if ln is an increasing function now, so whenever you are applying any polynomial function inside this, it will just exaggerate the value of this function. It doesn't do much. It will just exaggerate, or it will not exaggerate, it will just diminish the function. Because most of the cases when in the further classes you will be going through the gradient descent or any other conditions in ml and all, you always will be using ln. Why do you use ln in most of the cases? That just to diminish the values, because earlier for the polynomial values you were getting very vast values, so after applying the ln the values are diminished a lot. So we were having 10,000. Now we have applied log 10ln. So this number has declined to 4, correct?
4. Yes,
This is the best way to apply. So basically, ln we use it in that way itself. We just to diminish the function's value, but the character will not change. See, if you are having 10k here or 1000k here, and if you are applying 1000 here, 1000 here, so the ln value will be 3. Basically, you can see that this value, as this number was greater than this number, 10,000 was greater than 1000, and from the after applying ln also, you can see that the 4 is greater
ln
than
of
3.
the 4 is greater. Yes.
Correct. So if you are just getting the idea of this function itself, the function that is inside ln, you can directly say that this will behave in the similar way, because ln is an increasing function. So ln doesn't do much. Ln just decrease or increase the function. Okay. So earlier, if the function was like this, so now the function will be something like this after applying ln. So only the values will decline, but the character will not change. So the behavior of this function as it is going up and down. So here also it will be same, up and down, but the number only will decrease. This is what the ln do. Okay.
Okay, sir.
Yeah. So any other doubt that you have from the questions, activity, and I guess tomorrow also you have a session for, I guess, doubts. Tomorrow is the problem solving session that you have.
Yes.
Morning,
Yeah, tell
sir.
me you have
7
any
p.m.
other doubt from activity question.
6.4 question number 3.
Question number 2 also.
Sir, I have doubt in
6.4 question. Okay. So question number 2, we'll just start solving faster. We'll just discuss, complete all the EQ, and then we'll close. So log 12 x minus 2 plus log 12 x plus 2 equals to 1. How will you solve this? This is simple, right? So basically you have to use the
x minus 2 into log x plus
log
2.
x plus log ay equals to 1, right? How can you solve this one? This is simple, right? We have the same base, you can multiply x and y, right? X and y.
Yes, sir.
So the same thing you have to do, not much you have to do it here.
But I got
Right?
plus or minus 2, sir.
Basically x minus 2 का whole into x plus 2 is
x
equals to
square
what?
minus 2 square.
This is what?
Log 12 to the power 0.
1, right? So how will you equate it? This is equals to 12 equals to x square minus 4, right? And this x square equals to 16. So x equals to plus minus 4. Plus minus 4, x equals to plus minus 4 should be the answer, right? Minus 4 you can't take it, because from here itself you know that x should be greater than 2, and from here x is greater than minus 4. So this will be considered as the domain. So x should be greater than 2. So x equals to 4 is the only condition that is satisfying this equation. Okay, and this domain part always you should be checking. Every time when you are solving the problem, you should be knowing what should be the value of x that you should be putting in this equation. Okay, here you got
Sir,
plus
can you
4 and
repeat
minus
how
4.
log 12 is equal to 12?
Okay, sir. It's clear.
Okay, so if we have, see, if you have been given log
Step
a
3, sir.
b equals to 1, how do you write this? A to the power, so this will go into the power, a to the power 1 equals to b. This is how you write it in log, correct?
Yes, sir.
Yes, sir.
So this from here itself, so 12 to the power 1 equals to x minus 2 into x plus 2. Or if you don't want, if you are getting confused, what you can do is log 12 x minus 2 x minus 4, it was 1, right? You can write it log 12 12. You can write it like this. Now log 12 got cancelled, so you are left with x minus 2 x minus 4 equals to 12. Is it clear now?
Yes, sir.
Next question. Which one is the next one?
Sir, 6.7, question number 2.
Can you skip 6.4? Anybody has any doubt from 6.4?
Question number 3.
6.4 question number 3, sir.
Okay, ln x square upon 4 ln x minus 1 equals to log 5. The number of solution you have to tell, right? How can you tell the number of solution? Can you do something here? Can you do something here? Base are same, right? What can you do it here? If the base are
You
same
can
and this is
divide.
subtraction, what can you do?
You
Divide,
can
right?
write
So
it as
x square upon 4 x minus 1 ln of this equals to 1, right? This is 1
yes, sir.
or
Yes,
what?
sir. Yes.
And you have ln equals to, so e to the power 1 equals to
ln.
x square
Yes, sir. So ln
for
e
x
to the
minus
power
1.
1.
Solve this one, you'll get the solution. I guess you'll be getting two solutions. Okay, is it clear to everyone?
Solutions we have to find, but we have
How
a
to
value
find
like
number
e,
of
right?
digits, sir?
Yeah, you have e here. This is
Number of
2.7
solutions.
or some value 2.71, and then you have to solve this. You can use the any method to solve this equation. You'll be getting the number of solutions that you want. Okay, and here you should be thinking that x should be greater than 1.
So which method, sir? Because we can't like do factors and all, na, right? Or like as in
You
the
can't do factors, but you
quadratic
can use
formula.
this method, right? Minus b
Quadratic
plus
formula.
minus b square plus 4ac minus 4ac by 2. This method you can use it to solve this. This is a difficult one, but okay, yeah.
Okay.
But other method you can use it. Let me think which other method will be simpler for this question. Can anybody has any idea?
They have asked only
From
for
here how to approach log.
the number of roots. So there we can just see if the discriminant is greater than 0.
Okay, this you can write it like this log. Okay, then you can't do. Yeah, number of solution it's asking, but the problem it can be 1 also, right? You can get a number where the solution for this equation will be x equals to 0.5. That can't be possible, right? You can't get any solution for this equation as
Yes, sir.
x
But sir,
less
we can do
than.
discriminant we can check if discriminant is greater than 0
That
equals
you can do. Yeah, that you can do. Yeah, correct. That you can do. Okay, that
but
you
that
can
is
do.
applicable to the initial question as well. Like even if it is an ln and all, what we are finding as a solution, the discriminant that is good enough.
For this equation, if you are able to, but you have to get the exact equation, right? Then only you can check for the discriminant, right?
We just got x square by 4x minus 1 equals e.
There from there you can get it. Yeah, from there you can.
And then we check the. My question is like that is good enough because however this thing is in ln and all, no, that doesn't matter. Like just finding the fact that discriminant greater than 0 comes is applicable to our initial question ln x square by 4. The solutions for that.
So that's the issue here. If you are even checking with the discriminant form, so you should be getting the exact value, the solution, right? Because discriminant, if the greater than 0 also you are getting, that means you are getting, okay, both the roots are like number is possible, but the problem is you're not getting the exact number. Maybe it's possible that the one solution was x equals to 1 upon 5, 1 upon 2, right? And that is not possible here because the solution should be greater than 1. The values, there's a number of solution. So you have to basically solve it. This type of problem won't come, but okay, this is for the practice, but that's fine. This can't be, it will be very hectic to solve this problem, okay? Just to get the root of the equation. And the root also, you need to check this also condition, that x should be greater than 1. So that makes it a hectic question.
So we can
Okay,
also do it by a
but you can't
properties of
take it for
log.
the discriminant. You can just get an idea, but here it is a log ln function is applied, so that's why you can't directly say that the number of solution is 2 or 1. Okay,
Yes, sir. That
yeah.
was my doubt. Okay, thank you.
You can't check it. Yeah, correct. So you are correct.
Okay, thanks.
Any other question from this 6.4?
No, sir.
Okay, let's move 6.5 now.
Question number 1, sir, 6.5.
Okay, question number. Yeah, so this problem I have discussed, right? So you have to calculate the number of digits. Okay, for any function, 8, 15, 7 square. So basically this is 15, 49. Okay, so how will you solve this? Take the log only, right? I told you, right? If you have number 1, number 110, 100. If you are taking log here, it will be 0. You're taking log here, it will be 1. You're taking 100, then this is 2. That means any number that is lying from 0 to 9, okay, so the value, if you are getting the value, it will be form of some alpha point some values, and alpha will be 0, right? Similarly, if you are taking any values from 10 to 99, the values will start the number, because I told you, right, the log doesn't do much. Log just diminishes the value. So log of 90 will always be between 1 to 2. It can't cross 2, because you already know that log of 10 is 1, log of 100 is 2. So log of 90 will always be from 1 to 2. So it will be something 1 point some 9 or some values, alpha, beta, gamma. Okay. So whatever the value that you are getting here, just add it 1. Okay. So here it was 1 plus 1. So if you have to calculate the number of digits for 90, that means the number of digits is 2. And how do you check that? You just take the value of log for 90, and whatever the value, the leftmost part you are getting, just add it with 1. You'll be getting the number of digits. So here also you will be doing the same thing. Just take the log of 1549. So 49 log of 15. So what is the value you are getting? What is the log of 15? Can you calculate the log of 15? You have a calculator or not? Log of 15 is 2. No.
No, sir, 1.01 something.
Okay, sir.
It's log 1.17. Okay, if you are multiplying this, multiply this with 49. What is the value you are
58.
getting?
58.
58 or 57 you are getting?
57 plus 1 add करेंगे.
So you'll be getting some 57 point something, and then this number we are carrying for. So 57 plus 1.
Okay.
This
Can you
58
explain
should be
this
the number
logic
of
again?
digits.
We have 1, 10, 100,
Yeah,
and
I'll
ln of
explain.
these values are 0, 1, 2.
Yeah,
Then
see.
how does it convert to digits?
See, it was 1, it is 10, it is 100, it is 10,000. Sorry, 1,000, not 10,000. So if you are taking log of this function, if you are taking log, it will be
Yes, sir.
0, right? You are taking
Yes, sir.
log of this, it will be 1.
One.
Log of this, it will be 0. 2. And
Two.
log of
Yeah.
this will be 3.
3. Yes, sir.
Okay. So if you are taking any number from 0 to 1, 0 to 9, sorry, 1 to 9, any number, let's for example, you are taking 9. So this value will be somewhere from, it should be between 0 to 1, right? Because log
Yes.
10 is 1 and log 1 is 0. So if you are calculating log 9, that means the values for log 9 will be between 0 to 1. So it will be somewhere 0 point some value. I don't care about
Yes, sir.
the number, but I just care about the leftmost part. It is 0 and then add it 1, because to get the number of digits. So 9 will be having 1 digit. Similarly, you can check it for this one, 900. 900, the number log of 900 will be from 2 to 3. It will be somewhere 2 point some alpha, beta, gamma. I don't care about this value. I just care about this one. So this is 2 plus 1. So the number of digits for 900 is 3. So this is 2 plus 1. That's it.
Okay.
Got it, right?
Yes, sir.
Okay.
Question number 2, sir.
Question number 26, sir. Question number 2. Hey, this question you just solve it from your side. Like, this is a formula based for like compound interest and all. Nobody's going to ask you. I don't know why did they put this question, but okay, if you want me to solve, I can just write the formula. What's the formula for this? Some compound interest and all. I don't remember the formula.
It's m times 1 plus x by x if it is the percentage, then x by 100 n, the whole to the power n t.
Hey, it's too difficult, man. It's like the formula.
Yes, sir.
Hey, this you can do it from your side. This. It's somewhere okay. I just did that principle. It's like if you have to compound thrice. So okay, suppose M was the invested money. Okay, you have some interest 5. So the sum formula is like this, right? 1 plus R by some n or something we write it.
R by n to the power t, nt.
Now this is your principal amount, right? This is the
Yes, sir.
amount after compounding it. Okay. So n is what? N is 3 here, thrice a year. T has been given or not?
No, we have to
T
find
you have to
t.
calculate. Okay. R has been given. This is 0.05%. What is n here? N has been also
3.
given. 3. And what else? P is given. This is?
No.
Okay, this P doesn't matter because
yeah,
because this
to find
P
when
M
does
is
it
like
happen 3
3M.
times. 3.
So this will be m into 1 plus 0.05 upon 3, and this is 0, this is 3t, 3t. Okay, m got cancelled, you're left with this one. You can take log now, ln you can take, and you're left with ln 3 equals to 3t ln 1 plus 0.05 upon 3. You can calculate the value of this. Can you calculate it? I guess 0.05. It will be somewhere 1 plus 0.167, right? Oh, sorry, 0. ln of this value into 3t. What is ln of 3? Some value. So t will be equals to ln of 3 upon ln of 1.0167. This will be the value. You can calculate it. I guess you'll get the answer. Okay, this is a formula, you can use it. This is like not important at all. This formula.
Yes,
Okay,
no any
is it clear?
question
Can you
from
move?
this graded.
Yeah.
Sir, can you please repeat, sir?
No any question from this topic in the graded assignments.
There won't be any question, I guess. They'll not ask you in the exam also, just for the practice. Can we move to 6.6? What is left? 6.6 and 6.7. We'll just tap up this one both. Is it clear to everyone? Till now it is clear to everyone, this log function, everything?
Yes, sir.
6.6. Which question? 6.6, both the questions are pretty simple, right? It's like very simple. 6.7?
6.7, question number 2.
6.7, question number 2.
2.
1 and 3 also.
1?
And
Hey, 1
3.
is pretty simple. 1 you have to calculate the value. That you have to use the calculator to calculate it. Okay. Or without calculator also. Without calculator, so you can't do it. But yeah. Okay. The second problem, right? What is the function is given here? Function is log of 10 x minus greater than. So do you know about this function? Are you aware of this function? Okay, if I'm writing x is 8.57, what will the value of this greater than the function? Greater than these are 8, right? Okay, so you are already aware, then put it right. So log of 10, 8.57 minus 8. What is the value you are getting? Log of 10, 0.57. Correct? So similarly, you can put any number of values, any values you are putting. So the d will be, you can put it from, okay, if you have to put it from, from 0 to 1, how many numbers you can get it? From 0 to 1, all the in the decimal form, how many number you can get it? Infinite, right? Infinite. So if d is a set, then it will be infinite set, right?
Yes.
So you can put it 8.558, 8.587, 6, 5, 4. So you can do anything, right? The number of the set will be having infinite number set. So cardinality will be what? Cardinality will be infinite, correct?
Yes.
What is the other thing that you have a doubt? So the other thing is the graph fx has an infinite number of vertical asymptote. Is this correct? See, if you have a function, so okay, leave this 3. Okay, fourth option. What is this fourth option? F is invertible. It's not invertible, right? Why it is not invertible? Can somebody tell me why is it not invertible? So you have a function log of 10. Log of x minus. See, if I am putting 9 of 0.57 or 8.57, will there be any change in the value of y? Tell me.
No, sir. This is at 0.57.
Correct. So at 2 point, you're getting the same values, right? So it will not be a 1, 1, and you can't get the inverse of this function. Okay. What is the other thing? What is the other thing that you have to do? What is the other option?
Range of the function.
question number, it was 6.7 or 6.8?
6.7, sir.
Question number
Okay.
3.
Yeah, 1 second. I'm just solving this. So it will not be having any inverse. And what is the other part? And the range of the
Sir,
function.
morning session question discussion activity.
What morning session?
Morning session, sir.
Tomorrow
Activity.
morning, huh?
Yes, tomorrow, sir.
Tomorrow, I don't know what will they discuss, but yeah, they'll discuss you the doubt for sure. So whatever the remaining doubt that you are left with, you can ask it tomorrow morning. So this is the last question that you are taking, right? Or maybe the last question will be the third one. So, and then you have the range. See, the range of the function, how can you say about the range of the function is R? Every time you are getting the number, all the numbers is between 0 to 1 only, right? So R, how can R be the range of this function? It's not possible, right?
Yes, sir. Yes.
Got it?
Yes, I got it.
Yeah. What is the other one? What is left? Everything's like 6.7.
Question number 3, sir.
Sir, tomorrow will be class on 8 to 10. Solve with us.
Yeah, tomorrow solve with us. So suppose x and y are positive real number, and then you have been given log of x2 plus log of y8 equals to 0. Then which of the following options are true for x and y? Okay. So the first option is what? X is equals to 2 and y equals to 1 upon 8. Is it correct or not? If you're putting x equals to 2 and y equals to 1 upon 8, is it correct or not? So from here, if you are putting 2 to 2, and if you are here putting log of 8 minus 1 or 8, you'll be left with 1 and minus 1. So this is correct. Okay. Now come to the third option. So the first, leave the first option is correct. Second option, x yq equals to 1. X yq equals to 1. So can you solve this problem? Can you solve this one?
Okay,
if you have log of x2 plus log of y8 equals to 0. Okay.
Yes, sir.
Okay, so this is log of x2 plus, can you write it like this of can we change it this equation itself
But
into a
actually, base is a different, no? X and y.
Sir, we can change base, sir.
Base.
Yeah,
Sir,
we can
base.
change the base. Yeah, correct. How will you change the base?
So take ln of 2 divided by ln of x
ln of 2, ln of x.
plus
Basically, not take ln of 2, just take it as a base of 2 only.
Okay.
Log of 2, log of x plus log of 8 or log of y equals to 0. Okay. Equals to log of 2 by log of x equals to minus of log of 8 or log of y. If I am taking 2 as a base, so this will be 1. So log of y equals to, and this will be what? This will be, what will the value of this one? If I am taking base as 2,
3.
Log of x into what?
3.
X.
Minus 3. Correct?
Why, sir, minus 3?
I just put it this side. Okay. So this is minus 3. Okay, this is fine. You can just bring it here. Log of y plus log of x 3 equals to 0, right?
Yes.
And then you can do it, right? You have a base, both have the same base. So you can put it something like this. Xq, you can put it here. You can just remove it from here. You can put it, right? You can put whatever you want to do, like log of x cube. You can do it, right? And then you can, if the base is same, you can y multiply with x cube equals to 1, because anything to the power 0 is 1. So this will be correct. The first option is correct. Second, correct.
Okay, sir.
Similarly, you can check it. Okay. So
Okay,
activity
sir.
questions is done. Yeah. So the remaining portion will be like tomorrow again we have a session. So we'll be discussing that.
Okay, thank
Sir,
you.
actually, I have not
Yeah.
give some minus
What?
3, sir. Minus 3, sir.
Yeah. No. What did I do is I just kept it here like this side. So this will be minus, right? This plus will become minus here. Correct?
Oh, okay.
Yeah. Okay. I hope this we have
Okay, sir.
discussed all the questions from the activity. Remaining we'll be discussing or whatever that is the problem you have we'll be discussing again. We'll meet again. Okay. So good night for today.
Okay, sir.
Okay,
Good
Hope
night.
you
thank you.
enjoyed the session. Yeah. Yeah.
Bye, sir.
Okay.
Thank you, sir.
Yeah. Bye.
Thank
Bye
you, sir.
everyone. Thanks everyone.
Bye, sir.
Yeah. Bye. Bye. Everyone. Yeah. The result will come, I guess, in 1-2 days.